today's video, we are going to create a project with an application of uh, analog input or reducing a analog to digital conversion, which is similar to experiment 5. So first we will create a new project. So we will click this icon and then next. So for this project, we will using a PIC 16F18875. So that is the controller that we are going to input here. So if we already fill the device needed or the IC needed, so we will click next and we will choose a compiler which is the ECE8 enabled to program our IC in C or C++ code. Click next and we will name this project as Summative 2 or 3. Here. We will name it as Summative 3. Then click finish. So as we can see, there is a loaded files in here. So now we are going to set up the pins and the oscillators and necessary peripherals to to this program with MCC or MPLAB code configurator. So we will click that icon and as you can see it is already loading. And now the only thing we need is to click save. So there. So first we will add the ADCC under the peripherals. So we will check on the peripherals the ADCC and click this green button or the add ADCC. Okay, so it is already added. And then we will proceed to our pin manager, which is here. But first, we will set the pin manager to our current package of the IC, which is the PDIP40. So as we can see, it is already set in the package or in the layout that we needed. So first we will set our port A4 pin as the output, or let's just say there. So we will set our port A4 to output, which is as we scroll back here in GPIO, which is pin 6. And we will also use port A5 as another output, which is pin 7, since we are going to use two LEDs for this project. So next, we will set port A0, which is here, to our input as an analog input. So since we already set our input and output pins, we should proceed to the pin module tab. We can see it here. So as we can see, we will configure these tabs. So for the GPIO pins, which are considered output pins, we will uncheck the analog. since our this two outputs required a digital input which can be converted using the ADCC. So now uh, we will rename this to we will rename the pins and able to program it with ease. So for this one, we will name it as LE LED underscore 1, and the other is LE LED underscore 2. There. But for this one, we will name it as LDR, since this project covers on how an LDR can be used as an uh, light detector circuit, which it can detect if there is light coming through the detector, and it will switch the corresponding LEDs assigned to them. So for this one, so I think it is already set. That is uh, the setting we need. So now we will proceed to our system module. So in system module, we will set our oscillator. So we will set our oscillator to high frequency internal oscillator, which is this one. And we will select our internal clock to 4 megahertz and its clock divider to 4. And we will make sure the low voltage programming enabled is checked. So as we can see, it is already set, so there is no need to set it up. So next we will proceed to ADCC. For this one, we will set our clock source uh, to frequency oscillator to ADC to AD clock. Then our clock uh, should be uh, set up to frequency oscillator divided by 2. So uh, as we can see, the thing that is need to be set up is already by default. So now we can set it up now. So the positive reference should be VDD, and also the negative reference is VSS, and the result alignment should be right. So this is the thing that we need. So we will click the generate button. As you can see, the generation of this file is complete. So we will go, wait, I'm sorry, there, to projects, and then source files, and to the main.c. So uh, we will since we never use interrupt, so we will not uncomment those following macros, but we will put our code for our corresponding LEDs. So first we will initialize the ADCC. there. And then next, we will create an if statement and able to uh, make our circuit work. So, to have a correct code in able to gather the data for the ADCC, we will go to mcc.generated files and to adcc.c. So as we can see, get single conversion is used to read the values that that produced by our LDR. So now we will go to copy this code, Control C, and go to main.c, then Control V. But the inside here should be replaced by the name of the pin 2, which is the LDR. There. And then it should be less than 512. Then we will set our code needed here. So let's see. LED1 should be set high, while LED2 should be set low. So there. If it is greater than 512, using the else statement, we can reverse the functions mentioned above. So we will copy this and then Control V. Then let's say this is low and this one is high. So there. So as we can see, so if the LDR is greater than 512, less than 512 rather, the LED1 will set high but LED2 will set low. Or else, the LED1 will set low but the LED2 will set high. As we can see, as we all know that LDR increases its value when there is when there is no light intensity. So it means that the resistance of an LDR goes higher uh, if there is no light detected on detected by the LDR. So this means that uh, LED2 is the indicator if, or rather both LEDs are the indicator if those uh LEDs are uh if the surroundings is dark, or if there is light on its surround or or if there is light on its surroundings. So since we don't put the resistance, since the values of an LDR or a potentiometer is ranging from 0 to 1023. So now, as we can see, our code is ready to be built. So we will click this hammer tool and then it's still compiling. As we can see, our build is successful and this code is ready to be uploaded on our IC. The code is already uploaded. So as we can see, the LDR is connected, the other end of the LDR is connected to 5 volts, while the other end is connected to 10 kilo ohms that is connected to ground, and it is in parallel with the wire that is connected to pin 2. Then this blue wire is connected to LED 1 pin, which is pin 6, and the red LED is connected to pin 7, which is the LED 2, and both LEDs are connected to the ground, and it is up, and pin 11 is connected to the VDD or positive 5 volts, and VSS is connected to ground. So we will try to power this up. So as we can see, the red LED, since the lights are on, the red LED is lit up, but the white LED is turned off. When we try to turn off the lights, the white LED turned on. So as we can see, the white LED turns on when the lights, or when the environment is dark. When the environment is well lit up, as we can see, the red LED turns on. Hope you like this video and see you again next time.